broadcast domains, and CSMA-CA. In networking, Layer 2 hardware, including switches, access points, and bridges, are programmed to forward broadcast messages so as to reach all hosts on the LAN. The area over which a broadcast message reaches is known as the broadcast domain, which is synonymous with the size of the local area network. Because the broadcast domain represents the interconnected topology of Layer 2 equipment, more switches, access points, and bridges equates to a larger broadcast domain. In contrast, however, routers do not forward broadcast messages and therefore mark the boundaries of the broadcast domain, that is, the boundaries of the LAN. When the broadcast domain becomes too large or populous, broadcast messages lead to broadcast storms, where normal host traffic causes LAN performance to suffer tremendously, noted by increased latency and reduced throughput. A good rule of thumb is to limit the size of a LAN to no greater than a couple hundred network devices before adding another local area network and address range. Building a new LAN is as simple as adding another router, or simply configuring another LAN interface on the router. However, a more cost-effective, practical way to add additional LANs to the existing infrastructure is to implement virtual LANs across the topology. As local networking continues to trend toward mobile computing, wireless design and planning becomes increasingly more important. Like switches, access points expand the broadcast domain, but face a unique challenge, since wireless stations in the same proximity by design compete for shared access to the wireless channel on which they transmit. Whenever two wireless stations attempt to transmit over top of each other, a collision can result at nearby receiver radios, necessitating a retransmission. In order to reduce the chance of collisions, the 802.11 wireless protocol relies on carrier sense multiple access collision avoidance, or CSMA-CA for short, which basically requires wireless stations listen before talking. Under CSMA-CA, if the station senses that the wireless channel is occupied, wait for a random amount of time, then listen again before transmitting. Despite reducing collisions, CSMA-CA is an imperfect access method, as demonstrated by scenarios involving hidden nodes, where a receiver hears two transmitters, but the transmitters cannot hear each other, whether due to proximity or physical obstructions, resulting in greater frequency of collisions at the receiver. And although mechanisms like request to send, clear to send, RTS-CTS for short, mitigate the effect of hidden nodes, CSMA-CA remains an imperfect access method, with upper limits on the density and volume of stations in a wireless coverage area.